Assalamualaikum and a very good day. My name is Nurul Syafiqah Kahar from University Putra Malaysia, and I would like to present my study entitled Development of Starch-Based Film Containing Essential Oils for Food Packaging Applications. Nowadays, starch-based film have been developing well in food packaging applications. Nonetheless, it exhibits poor properties that limit their application for conventional food packaging. The incorporation of additives, particularly in this study, essential oil, has an impact to the starch polymer matrix in terms of its optical and mechanical properties. In this work, the effect of three types of essential oils at different concentration on starch-based film were investigated. Its application as an efficient food packaging was evaluated on strawberries for 9 days storage. The objectives for this study are firstly to produce and characterize starch-based film incorporated with different types of essential oil and concentrations in terms of mechanical and optical properties. Second, to investigate the shelf life of strawberries wrapped with the film stored at chiller at 4 degrees Celsius in terms of weight loss, color changes, and firmness. For the preparation of the films, it begins with the tapioca starch dissolved in distilled water glycerol solution, and then the mixture being heated under continuous stirrer, and then the solution was added with EOs at different concentration. Next, the solution underwent ultrasonication for 5 minutes to homogenize the solution. The 50 ml of the solution was poured onto the petri dish and being left to dry for 2 days in air-conditioned room. After that, the films being peeled off and conditioned at 54% RH and 27 degrees Celsius. The characterization of the films begin with the determination of its optical properties using color spectrophotometer, then its mechanical properties using texture analyzer to determine the tensile strength, elongation at break, and Young modulus of the film. As for the application of the films, the strawberries were first selected and wrapped with the films. The unwrapped strawberries also were prepared as a control. Then the strawberries were stored at chiller at 4 degrees Celsius, and then the weight loss, color changes, and firmness were evaluated at 0, 3, 6, and 9 days. Next, for the results and discussion part, first of all, the thickness were measured, and based on the graph here, it shows that the addition of essential oil to the starch film increased the thickness due to the difference in the material concentration of essential oil, even though the same volume of solution was poured. Thus, the total solid contents of the film increased after the drying process due to the increase in film matrix constituent polymers. Next is the film optical properties. Firstly, as you can see in the table here, there was a decrement of lightness, which is shown by the L value, with the essential oil addition indicate a slight darkening of the films. There was also a loss of redness in terms of its A value of the film when incorporated with the essential oil, as the film tend to become yellowish, indicated by the increased strength of the B value with the increased concentration of the essential oil into the starch film due to the natural color of the oil. Okay, here in the graph, we can see that there were an increasing trend of the total color difference with the increased concentration of essential oil added, indicated a slight color variation of the films. Also, the opacity of the starch film increased slightly, as you can see here in the next graph, with the addition of essential oil indicated a decrease in film transparency. Nonetheless, the variation was small and non-noticeable. Next part is the film mechanical properties part. The table here shows that there was the decrement of the tensile strength when the essential oil is added due to the plasticizing effect of the oil. The EAB value, the elongation at break value of the film increase, shows that the film become more flexible with the addition of the essential oils due to the strong intermolecular polymer-polymer interaction, which were partially replaced by the weaker polymer-oil interaction. And finally, the addition of the essential oil into the starch film reduced the Young modulus value of the films due to the essential oil acted as a plasticizer, which increasing the mobility of the starch chains, thus reducing film rigidity and stiffness. Finally, for the film application on the strawberries generally experience weight loss, but the application of the starch with essential oil film managed to reduce the weight loss experienced by the strawberries. And as you can see here in the graph, all the strawberries also experience a loss in firmness at the end of the storage, but it is much higher for unwrapped strawberries compared to wrapped strawberries. It concludes that the film managed to protect the strawberries from water loss and respiration rate. They can affect its weight and firmness due to the improved film's barrier properties. Based on the figure here, the strawberries experience loss in lightness and redness during the storage, but it were more pronounced in unripe strawberries, indicating that the films can efficiently preventing color deterioration of the strawberries. In conclusion, the addition of essential oils into the starch film improved the properties of the films in terms of its flexibility and stiffness, and the films are promising for food packaging application, especially for the extension of the shelf life of the strawberries. The starch film incorporated with the 1% concentration of Vietnamese mint essential oil were the most effective film because they exhibit high flexibility and lower stiffness. The films exhibit lower opacity and high transparency. The films also managed to reduce the weight loss and maintain the firmness of the wrapped strawberries at the end of the storage. And that's all from me. Thank you.